Okay, I'm going to begin section 11.5 now. We're going to talk about the algebra of functions. More specifically, we're going to talk about operations with functions. We'll start with the basic four operations like add, subtract, multiply, and divide. And then we'll talk about another operation in this section, which is called function composition. So just like when you add, subtract, multiply, and divide numbers, you can do the same operations with functions. Okay, and the end result will always be a function. So if you have like two functions, f of x and g of x, and f of x is equal to x squared plus 5 and g of x is equal to 2x minus 14, f of x plus g of x would be just where you'd add these two expressions together and combine your like terms. Now x squared plus 2x minus 9 would be a brand new function, and we would call this the sum function, f plus g. Similarly, if you were going to multiply f of x and g of x, okay, well we're given formulas here, right? So we just multiply the expressions that were given. You'd have to FOIL this out, and you get 2x cubed minus 14x squared plus 10x minus 70. Okay, now that function would be a brand new function, which we call the product function, f times g. In general, if f and g are functions, then the sum function, f plus g, is defined by f plus g of x, and you just simply add the two functions together there. The difference function, f minus g, is defined by f minus g of x, and you'd be just subtracting the two functions. The product function, f times g of x, is where you're going to be multiplying the two functions. And then the quotient function, f divided by g of x, is where you would divide f of x by g of x. And just like with numbers, you can't divide by 0. Same thing with functions. G of x can't be the 0 function. Let's take a look at problem 33. We want to consider the functions f of x equal x plus 5 and g of x equal x squared plus 3x minus 10. We're going to do some calculations here. Part A, we want to find f plus g of x. Well, that's the sum function, which by definition means that I just add the two functions together. So f of x is x plus 5, g of x is x squared plus 3x minus 10. I don't really need parentheses here because I'm not distributing anything. I would just combine my like terms. X squared and then 3x and x is 4x. 5 minus 10 is minus 5. And here'd be my answer then. Okay, part B, f minus g of x means that I want to compute f of x minus g of x. That'd be the difference function. And I'm just going to subtract these two expressions. The only thing I would add, now here you'd want parentheses because you're going to be subtracting g of x, the whole thing, and you'll want to distribute the negative there into the three terms. So we're going to have, let's see, negative x squared. X minus 3x is negative 2x. 5 plus 10 is 15. And here'd be my answer. The product function means that you're going to multiply f of x and g of x together. I wrote down the two expressions there, and I want to distribute. The way to do this one is, okay, you're going to distribute x into these three terms for g, and then distribute 5 into these three terms for g, and then combine all your like terms. So let's do that. X times x squared is x cubed. X times 3x would be 3x squared. X times minus 10 is minus 10x. And then plus 5 times x squared is 5x squared. Plus 5 times 3x is 15x. And then 5 times negative 10 is a minus 50 at the end. Combine your like terms. You got x cubed, and then 3x squared plus 5x squared is 8x squared. Negative 10x plus 15x is plus 5x. And then we get a minus 50 at the end. Okay. And then there's the quotient function. You're going to divide the two functions. And now the denominator, so g of x is actually going to factor as x plus 5 times x minus 2, and that will conveniently allow me to cancel the x plus 5's here and leave me with 1 divided by x minus 2. And of course, simplify like you would any other problem here. All right, so I've been able to find some general formulas here for the sum, difference, product, and quotient functions. Now, like any other function, I can plug in numbers and I get input and output values. So like if I want to find f plus g of negative 2, well, just like what it was for x, you take f of x plus g of x, you can do the same thing here. It'd be f of negative 2 plus g of negative 2. F of negative 2 is 3. G of negative 2, negative 2 squared is 4, minus 6 is negative 2, minus 10 is negative 12. Okay, 3 plus negative 12 would be negative 9 is the answer. Now, another way that you could do this is you could use this formula that we created. All right, so like if I plug in negative 2 into this formula that I created, negative 2 squared is 4, minus 8 is negative 4, minus 5 is negative 9. Like you still get the same answer, okay? Part F, f minus g of negative 4. Well, here's the formula that we created for f minus g of x. And you can handle the calculation the same way you did when it was x. You're going to take f of negative 4 minus g of negative 4. F of negative 4, negative 4 plus 5 is 1. And then g of negative 4 squared is 16. Plus, let's see, it'd be a minus 12 is 4, minus 10 is negative 6. 1 minus negative, so 1 plus 6 is 7. Another way that you could have done this is just, plug it into this formula. I mean, you're creating this formula, so if you're not going to use the formula, why get a formula if you're not going to use it type thing. So you could also plug it into the formula here, right? We have x is negative 4. So negative 4 squared is 16. You got a negative in front of that, so you're going to have negative 16 leading off, and then it's going to be plus 8, that's negative 8. Plus 15 is 7. Okay, so you still get 7 if you just plug directly into this part. Okay, how about f times g of 1? Well, that would be the same as f of 1 times g of 1. F of 1 would be 6, right here. And then g of 1, 1 plus 3 is 4, minus 10 is negative 6. 6 times negative 6 is negative 36. And of course, I could also just use the formula that I've created right here. So negative 1, or let's see here, 1 cubed is 1, plus 8 is 9, plus 5 is 14, and then minus 50 would still give me negative 36. Either way, I mean, as long as you're still just getting this, the right number, I wouldn't care which, where you're inserting it into there. Part H, f divided by g of 5. Okay, so that's the same as f of 5 over g of 5. F of 5 is 10, and g of 5 squared is 25, plus 15 is 40, minus 10 is 30. 10 over 30 is 1/3. And you could also just use this formula that we got. Okay, if x is 5, you'd still get 1/3 as the answer there. Again, either way is fine. Okay, now there's another operation that we need to know in this section, which is called function composition. And I'll talk about that in the next video a bit.